Hi everyone, the video for today is going to cover exponential regression using your TI-84 calculator. So we have the situation and a table that models it, and we're going to use our calculator to pull out some information and solve some of the things we want to find out about this model. So the model covers your sister making soup, and once it's heated, she's taking it off the stove and leaving it on the counter, and obviously it's going to cool on the counter. So the table shows the temperature of the soup in degrees Fahrenheit over a 12-minute period. So we're going to use this table to solve some exponential regression equations and questions. So we're going to start by entering the data from our table. So we're going to enter the data from this table into our calculator in L1 and L2. And to get to L1 and L2, that's list 1 and list 2, you can click stat and it'll come up with this screen, and you want to click enter on edit. I have already entered the data into my calculator just for the sake of time. But if you would like to enter it for yourself, you can type 180 and then enter, and then 162 and enter, and you keep having to click enter on each one to make sure it inputs properly. So once all of them are in, your X values, which in this case are minutes, and Y values, which in this case are temperature, are in your L1 for X and L2 for Y, we can make a rough scatter plot for this data. So to get our scatter plot, we're going to hit the zoom button in the top center of your screen. And you can either scroll down to number 9, which is zoom stat, or you can just click the number 9. So if you click the number 9, it'll come up with a rough sketch of what we are working with. So this is clearly decay, which makes sense because our soup temperature is going down as time goes on, because when you set it on the counter, it's going down. So that is a rough idea of what we're looking at. Now, we're going to make a regression equation. I am going to store it in Y1 on my calculator. I'm doing that just because I want to be able to look at a table that's comprehensive when I'm finished. So I'll show you that in the future, but if you don't want to store it, you don't have to store it. I'm going to be storing it in Y1. So to get your regression equation, we're going to go back to the stat menu. And remember, the stat menu is where we entered our values from our table. Once you're there, we're going to go over to calculate because we're trying to calculate our regression equation. And we're going to scroll all the way down to the number 0 because it says EXPREG. EXPREG stands for exponential regression. So I'm going to show that one more time. Click stat, over 1 to calculate, and then down to 0, which is your exponential regression. You can either hit the number 0 or hit enter on 0, and it'll come up with this screen. It'll say EXPREG on top. That means you know you hit the right button. And your X list will be labeled as L1. And L1 is where we entered all of our X values to begin with. If it does not say that, you can clear out whatever's there by clicking clear and then clicking second and then whatever button you entered the list on. So in this case, I'm hitting 1 for L1. Then you can scroll down your Y values, and we entered our Y values in list 2. We don't need to add a frequency list for this, but we can store the equation. And again, this is optional, but I'm going to show you how to store the equation. You're going to click VARS, the VARS button, VARS, scooch over 1 to Y vars, and then it'll be highlighting function. Click enter on function on enter on Y1. Now the equation from our calculator is going to be stored in Y1 of our calculator. Next, we can scroll down and then we can calculate our regression equation. So I'll go ahead and click enter to calculate. Our regression equation is going to be y equals a value is the first thing that comes up. So 179.981. I'm going to round to 3 decimal places. So 179.981. And then the b value is the second value that comes up, and that's 0.949. And you're going to raise all of that to the x power. And if you're not sure how to do that, if you look at the very top of the screen, it will say a times b to the x power. So you take the a value it gives you, multiply it by the b value it gives you, and raise it to the x power. Your correlation coefficient is your r value. So that is the one on the very bottom. And that value represents how closely this model that the calculator generated models an exponential function. So does this data model an exponential function? It models it at a 99.999%, right? So it's very, 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 very close to a exponential function. That is perfect. So I'm going to write it like this, and you'll notice it has a negative in front, and negative means it's a negative relationship. We know it's a negative relationship from our scatter plot up here because it goes down. So whenever it's going down, it's going to be a negative relationship. Whenever it goes up, it's going to be a positive relationship. So this R value tells us that this data has a negative strong relationship to a exponential model. So it's really, really close, but not quite perfect. Then our coefficient of determination shows how well this model, so the other one's about our data, how well this model fits the data that we're given. So our coefficient of determination, our R squared value, is also 0.999. So I'll just leave it like this. And now we're going to interpret a point from our table. So the point we have here is 4, which is our x value, and 145.8, which is our y value. Our x value was minutes, so we have 4 minutes, and our y value is temperature, so 145.8. So to interpret this, we can say at 4 minutes off of the stove, our soup is 145.8 degrees Fahrenheit. So just look at what your x values are and what your y values are, and then attach them to the numbers. We're going to predict the temperature of the soup after 20 minutes has passed. So remember, your minutes is your x value. So this is why I wanted you to store your y equation in the calculator, your equation as y in the calculator, because now that it's stored, we can do no math to figure this out. We can just go to the table to see what our y value would be when our x value is 20 minutes. So to get to your table, you'll see it says table in blue right above your graph. That means you have to hit the blue second button first, then hit graph to get to your table. This will have a XY coordinate pair for every single point for this model. So I'm going to scroll down to when x is 20, and I'm going to have 62.789 degrees Fahrenheit. 62.789 degrees Fahrenheit. So after 20 minutes, it'll be at 62 degrees if it continues to follow this model perfectly. If you did not store your regression equation in y equals of your calculator, you could also just plug in 20 for x into this equation up here, and you'll get the same answer or a very, very similar answer. Keep in mind, we rounded, so it might be off just a tiny bit, but it'll be very, very close to that. And then we're also going to see what our x value is when the soup is 81 degrees. So 81 degrees is our y value. I'm going to look in my table to see if I can find something around 81 degrees. I see it right there. So approximately how long has it been with the soup on the counter if the soup is 81 degrees? I can look over at my x value there, and it looks like it's about 15 minutes. Okay, that was our first model. So I have one more for us to practice. So we will restart. Before I restart, I do want to mention 2 things. Certain people, when they calculate their regression equation, so when they go here and they click calculate, the R squared and the R values are not showing up. If that happens for you, you can turn them on by clicking second 0 to go to the catalog and pressing and holding the down button until you see the words diagnostics on, and click enter on diagnostics on 2 times. So it looks like this. If your R and R squared values are not showing up, click enter on diagnostics on, and then enter again, and it will turn them on. And then it should show up when you calculate your regression equation like that. You should have your R squared and your R values. The other thing that sometimes doesn't come up is your scatter plot. So when you click zoom 9, if you are not seeing a scatter plot, keep in mind, sorry, that line is there because I stored my equation. So don't worry if your line's not there. But if your scatter plot is not showing up, it probably means that your stat plot is turned off. So if mine's off, I'll turn it off really quick to show you what it looks like. And I click zoom 9. It won't have any points on it. So I have the line there because I have something stored in my y equals, but there will be no points there. So to get those points to show up, you have to click second y equals to go to your stat plot screen. Click enter on whatever plot you want it to show, and then I just do the first one. Now, when you click zoom number 9, it will come up with the points that you entered in L1 and L2 of your table. Anyway, if anything's working for you, you won't need those tips, but if those things are not working for you, you can go into those menus to get them to turn on. All right, let's do this one more time. So a scientist is studying how bacteria grows in their lab. They start with 3 bacteria and log their growth every minute as the bacteria grows. The table below shows the number of minutes that go by and the quantity of bacteria that are present in the lab. So we're going to enter all of this in L1 and L2 of the data. These are going to be my X values. These are going to be my Y values. My X values go in L1. My Y values go in L2. So I'm going to click Stat, Enter. I already have a bunch of data in my L1 and L2. So to clear it out, I have to go up to where it says L2, click Clear, and then Enter. It clears out the whole list. To clear out L1, I'll go up to where it says L1, click Clear, and Enter, and then the whole list is gone. Now I'm going to re-enter my new data, starting with my X values in L1. So remember, you have to click Enter after each one of your entries. When you're done with that, you can just click over one and enter your L2s. Keep in mind, if you have like 3.0, like our first number, it will not put the 0.0 in to your table because it's extra and it'll just round it to the whole number. So don't worry if when you're entering it, it doesn't have the 0.0 listed. It's totally okay. Okay, once you have all of your data entered in L1 and L2, we can make our scatter plot by clicking zoom and number 9. And you'll notice that I still have a line showing in my scatter plot. The reason I have that is because I still have my old equation stored in Y1. So if I click Y equals and clear it out and then click zoom in number 9, it'll just be my data. You can see that this data is clearly exponential growth. It's something like that. And we can draw in all of our dots. It is shooting up pretty rapidly. So this bacteria is growing at a very fast rate. Next, we're going to calculate the regression equation and I'll store it. So to get your regression equation, you'll click Stat, right arrow, go down to 0. We want our X list was listed in L1, Y list was listed in L2, and then our storage you do by hitting vars, that's VARS. Write 1 to Y vars, click enter on function, enter on Y1, scroll down to calculate, and click enter to calculate. You should see the words EXP, REG on top, exponential regression, to make sure you hit the right button. Our regression equation is Y equals the first value that they give us, 2.4942. So 2.942 is our A value times our B, which is 1.995. And then you raise it to your X power. Our correlation coefficient is our R value, which is 0.9998. So it's how closely it models an exponential function. And this is a positive, strong relationship. Our R squared value shows how well this model fits the data. And it's 0.999 as well. So it models it 99.9% accurately. So this is a very, very strong relationship here. We're going to interpret the 0.5, which is our X value, 95, which is our Y value. So our X values were minutes and our Y values were bacteria. So we have 5 minutes and 95 bacteria. It looks like in our table we have 590. So I'm just going to change this to 90. Excuse me. Sorry about that. So we'll say 5 minutes have gone by and 90 bacteria are present. 5 minutes have gone by and 90 bacteria are present. All right, and this is why we stored our equation in y1 of the calculator, because now instead of plugging in 11 for x and 93 for y, we can just go to the table and see where x is 11, what our y value is, and when y is 93, what our x value is. So to go to your table, you can hit second graph, and it looks like I already am right next to 11 on my screen. So the number of bacteria present after 11 minutes has passed is 5,870.9. And if you want to round further, like if you want more decimal places, just hover over the y value we're looking at and it will give you the rest of the data. So it will go on for quite a while. So there are about 5,800 bacteria present after 11 minutes. And how long has it been if there are 93 bacteria? So we're going to have to go way up in our y's to see when we have 93 bacteria. So 93 bacteria, it looks like it was about 5 minutes after we started. So about 5 minutes, we had 93 bacteria.